This lesson, we are looking at quadratic sequences. You might be wondering, why do we need to learn quadratic sequences? Think of quadratic sequences as like a personality of the whole person algebra. If you're interested in a person, maybe you aren't, but you are forced to learn about this person algebra through a GCSE, and you're attracted to it, of course you will learn more about his or her other side of personalities, right? So quadratic sequence is one of them. It's like learning, getting to know someone. Anyway, learn objectives. We're going to learn how to recognize and generate quadratic sequences. We're going to learn how to find the nth term, which is the most important thing. We're going to learn how to use the nth term to calculate terms. And we're going to solve problems using quadratic sequences. As a starter, would you like to have a go at a question 1 and 2?
What's not the question?
When you're ready for the answer, you can press play. Here are the answers. Question 1, make sure you put in x equals 2 in both positions of x. And when you do this, if you've used a calculator, then ignore what I was going to say. But if you haven't, make sure you use bitmask properly. A silly mistake a lot of students will make, especially quite evident later when we do similar things later. Question 2, this is what we call a quadratic equation. To solve a quadratic equation, you must make one side equal 0. So the first thing we do is we bring the 11 to the other side to make it minus 11, so it becomes minus 24, and then we factorize, and we get our two answers. A quadratic sequence is a sequence in which the second difference between the terms are constant. So if we look at this diagram here below, the top here is called as the quadratic sequence, it's called sequence. But if you look at the first difference, we're adding 4, adding 6, adding 8, adding 10. The second difference is constant. So you can see that plus 2 plus 2 plus 2 here is constant. So therefore, the first difference in here, in here, forms a linear sequence itself. 4, 6, 8, 10. If you forgot what's a linear sequence means you're adding and subtracting by the same number. So in here, 4, 6, 8, 10 is clearly a linear sequence. So we are going to conclude this sequence on top in here a quadratic sequence. So the main definition for quadratic sequence is that the second difference is constant. It means it's the same throughout. Okay, so the nth term of a quadratic sequence has the form an squared plus bn plus c, just like a quadratic expression, where a, b, and c are constants to be found. So you have to find the a value of a, b, and c and put it in. Right, to find the nth term of a sequence, I've made you an IKEA menu. First step in here, what you have to do is you have to find the zeroth term of each line. So if that's the first term, this is the first term. Okay, this is the first term. Second term. So you can see 2, 6, 12 is the same as the one on top. But you find the zeroth term, the number in the front. And then you're going to make each line equal to the expression. You're going to make the top line equal to c, second line equals a plus b, and the third line equals 2a. And then once you find the value of a, b, and c, you're going to assemble into an squared plus bn plus c. Sounds simple, just like the IKEA instruction book. It looks thin and, just a few steps, nothing too difficult. But when you do it, it's so much effort. Right. When I taught this topic a few years ago, I think it was a World Cup, and we were watching football in school, and some students came up, and she was a big fan of Cristiano Ronaldo. So C, A plus B, and 2A, take it or not. Okay, up to you whether you want to take it or not. So this is how she remembers the C, A plus B, and 2A lines. So C stands for Cristiano, of course, Ronaldo. A stands for and. B stands for Beckham. 2, A stands for attractive. So Cristiano and Beckham, 2 attractive. So that's how you remember C, A plus B, 2A. If you don't like Cristiano, Ronaldo, or Beckham, feel free to replace the C and the B with a different name that you like. Okay, maybe the crush that you like. Crushes, because we've got 2 people. In the first example, I'm going to lead you through how to identify a quadratic sequence. So to identify a quadratic sequence, you want to work out their second difference. So like this one, 1, 1, 2, 5, 8. what I'll do is first I'll work out the first difference. 1 and 1 is 0. 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 3 is 5. 5 plus 3 is 8. And then through these numbers, I'm going to work out second difference. 0 plus 1 will give 1. 1 plus 2 will give 3. 3 plus 0 will give 3. So is this a quadratic sequence? The answer is no, because if you compare this to the notes, to qualify a quadratic sequence, the second difference must be constant. Now this is not constant. Constant means the same number. So this is not a quadratic sequence because the second difference is not a constant, or it's not the same, you can say. Okay. Some of you might be thinking, oh, hang on a minute, I recognize this pattern. Is this a Fibonacci sequence? The answer is also false, because Fibonacci sequence means you have to add the previous two terms to find the next term. So 1 plus 1 is 2, but 1 plus 2 is not 5. Okay, so it looks like Fibonacci sequence. If you have to change your Fibonacci sequence, if you add a 3 in there, then that will work, I think. Yeah. Okay. Right. Example, next one. Given the nth term of the quadratic sequence is 2n squared minus 3n plus 1. Remember, the nth term is like a name of a sequence. We can use it to work out all the terms in there. Work out the first 5 terms. So to work out the first term, we sub in n equals 1. So when n equals 1, we put in 2 times 1 squared minus 3 times 1 plus 1. If you can, try not to use a calculator just to practice your mental maths. When I was a kid, I try to do mental maths in every single way when I can. I'm a bit of a geek, but anyway, I love doing the silly mental maths, like supermarket when you buy two things together, and I'll just try to work out quickly before my dad can do his estimations on how much he has to pay for it. Anyway, so that one's 2 times 1 is 2, minus 3 is minus 1, plus 1 is 0. When n equals 2, 2 times 2 squared minus 3 times 2 plus 1. So 2 squared is 4, 4 times 2 is 8, 8 minus 6 is 2 plus 1 is 3. N equals 3, similarly. So every time we're just going to change the value of n, you can see in here, which gives me 10. So when n equals 4, I'm going to write the steps in here once, just in case, if you want to complete the notes. 21. When n equals 5, you do 2 times 5 squared minus 3 times 5 plus 1, which is 36. So the sequence goes 0, 3, 10, 21, 36. Here comes practice question 1. Work out the first 5 terms of each of the following nth term. I'll let you decide if you want to use a calculator or not. Okay, have a go, pause the video. When you're ready for the answer, you can press play. Here are the answers. So question A, the sequence goes by 4, 10, 18, 28, 40. Second one, 4 minus 1, minus 10, minus 23, minus 40. And C, minus 2.5, negative 1, 1.5, 5, and 9.5. Next, we're going to learn how to find the nth term of the quadratic sequence and find the 10th term. So example question A, 3, 6, 11, 18, 27. So let's begin with, I'm going to rewrite the question, but I'm going to leave some space in the front. I'm going to split numbers a bit wider as well. Okay. So remember, Cristiano and Beckham too attractive. So first thing we need to do is to find the first difference, the second difference, and find the 0th term. So first difference is 3, 5, 7, 9. Second difference, 2, 2, 2. Perfect. Next step, we're going to find the 0th term. To find the 0th term, we start from the bottom, like a pyramid. We start from bottom. 2, 2, 2, the previous must be a 2. This one, a 3, 5, 7, 9, the first number must be 1. Now this one, something plus 1 equals 3, this term must be 2. Next, Cristiano, C, and Beckham, AB, so A plus B, 2 attractive, 2A, equal. Okay, so from here, what we can get is, we know C equals 2. Now 2A equals 2, so A must be 1. If A is 1, 1 plus something is 1, B must be 0. So therefore, the nth term Therefore, the nth term, that's an squared plus bn plus c. Now it must be, now it becomes a is 1, so n squared plus bn, that's b 0, so there's no n term, plus c, n squared plus 2. Okay, so to verify it, which is a quite important step, which you do want to try to do every time. So verify. So when we sub in n equals 1, when n equals 1, 1 squared plus 2 is 3. When n is 2, 2 squared plus 2, which is 6. When n equals 3, 3 squared plus 2 equals 11. And it matches with the sequence, so we know that's correct. Last but not least, when you find the 10th term, we sub in n equals 10 in there, so 10 squared plus 2, 100 plus 2, 102. Okay. Question B, 10, 17, 26, 37. Let's do on the side in here. Question B, 10, 17, 26, and 37. First step, again, work out the first difference. That's 7, that's 9. Am I right? Yep, and that's 11. Second difference, 2, 2. Perfect. Next step, work out the 0th term. 2 and 2, the previous must be 2. Something plus 2 equals 7, that number must be a 5. Something plus 5 equals 10, that number is 5 again. Cristiano and Beckham, 2 attractive. So what we know is, we know C equals 5, A equals 2, A equals 2, A equals 1, 1 plus B equals 5, B must be 4. So the nth term is going to be, so I'll write again, an squared plus bn plus c. It's time to assemble. A is 1, so 1n squared. B is 4 plus 4n. C is 5. Do not rush to next part yet. Verify it. Now these are quite mistake prone, so do make sure you verify it. So we're going to verify or double check. So n equals 1. 1 squared plus 4 plus 5 is 10. When n equals 2, 2 squared plus 4 times 2 plus 5. 4 plus 8 is 12, plus 5 is 17. We've done 2 numbers. Usually that's good enough. It's a good indication that we've done it correctly. If you're unsure, you can do one more. So then to find the 10th term, we'll just sub in n equals 10. 10 squared plus 4 times 10 plus 5. 10 squared is 100. 45, so 145. Okay. Question C. This time with decimals, but same thing, but this time it's also decreasing, but it's the same thing. 1.5. So let me copy the question in here. Question C. 1.5 minus 2 minus 6.5, negative 12. First step, work out the first difference. So from 1.5 to minus 2, we are subtracting 3.5. From minus 2 to negative 6.5, we're subtracting negative 4.5. We're subtracting 4.5, always negative 4.5. From negative 6.5 to 12, we're subtracting 5.5. Find the second difference. Every time we're going down by negative 1. So let's work on the previous term, okay, the 0th term. Now, if you need help with decimals in here, feel free to use a calculator. I would assume numbers like this, you will have a calculator to work with. Just be careful with the signs in there. Because students might be thinking, oh, 3.5 to 4.5 is a positive 1. But no, you're going down by 1 each time. So be careful with that signs. Start from bottom, minus 1, minus 1. Previous term is minus 1. Next one, if you look at this, negative 5.5, negative 4.5, negative 3.5. This must be negative 2.5. Now this one, something minus 2.5 is 1.5. So to work out this number, we can do 1.5 plus 2.5, which is 4. Okay, next, Cristiano and Beckham, 2 attractive. So what we've got is C equals 4. Now 2a equals minus 1, so we can write B and A. A is going to be negative a half. Now, A is negative a half. Now, do take some time to work out the value of b carefully. So if a is minus 2 point, a is minus a half, let me use different color, minus a half plus something equals minus 2.5. So that something must be minus 2.5 plus a half, which is minus 2. So value of b is minus 2. Okay, so once we've got that, then we can work out our nth term. Our nth term is going to be an squared minus a half n squared plus bn, but b is negative 2, so negative 2n plus 4. Verify, double check our answer. You should do that in exam every single time. So when n equals 1, minus a half times 1 squared minus 2 times 1 plus 4, plug in the calculator, is 1.5. Next one, when n equals 2, minus a half times 2 squared minus 2 times 2 plus 4 is minus 2, so it works. Okay, so that means we know we're correct. Next, to find the 10th term, we're subbing 10 in there. Minus a half times 10 squared minus 2 times 10 plus 4, which gives you, putting calculator, minus 76. It's your turn to have a go to work out the nth term and the 10th term of the following sequences. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Solutions. So there's nothing I really have to say apart from this one. A slightly trickier to find the value of b. So yeah, this is the last part in quadratic sequence that I have to go through with you. So the last example, given the nth term of sequence n squared plus n plus 1, determine whether 91 is a term in the sequence. To figure out if a term is in a sequence, you'll make the nth term equal to that number. Now you're not working out the 91th or the 91st term. You're working out if 91 is the term. So you're going to equate it. Okay, equate it. Now what happens is, if 91 is a term, okay, so if 91 is a term, then n is a positive integer. So you get a positive integer whole number as an answer. If 91 is not a term, then you get a decimal or negative number or negative answer. Okay, right, so this is what we're going to do. We're going to solve the quadratic equation. First thing first, we're going to bring 91 to the left hand side. So we subtract 91. So n squared plus n, subtract 91 means minus 90 equals 0. Can it be factorized? 90, 10 and 9. Yeah, it works. So n plus 10 and minus 9 equals 0. So n equal minus 10 or n equals 9. So therefore, for n equals minus 10, n is the term. So we cannot have a negative term. So we're going to reject. Put our ej in here means reject. So we'll say, therefore, 91 is a term in the sequence. It is the 9th term. The next two practice question, I made it to be one on calculator, one calculator paper, just to give you a taste of, in exam, you will encounter similar situation. So pause the video, have a go at question 3 first without a calculator, and yeah, when you're ready for the answer, you can press play. Here are the answers. Now, question A, some of you, when you do this question, you might be thinking, hang on a minute, how is C5? Have we not got 5 in here already? Now remember, quadratic sequence also resembles the quadratic graph. If you remember, what does a quadratic graph look like? Quadratic graph looks like a parabola, like a U-shape. That means there could be a U-turn. So when the value is 5, you could have the value of 5 again because it's a U-shape. So you could have multiple values in the quadratic curve. What it means is, in this quadratic curve, quadratic equation expression n squared minus 2n plus 5, somehow between 4, somewhere near 4, 4 is close to turning point. That's why you have a U-turn of numbers 5, 4, 5, and then 8, 13. So, right. So work it out. Just be careful with the numbers. And then see what I did in here. I do verify it every time. And then to make it equal 104 and factorize it, and we work out an answer. So, and we work out it is the 11th term. As I've said, this is the last practice question. This time you can do with a calculator, feel the difference of the question in terms of numbers. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. Hopefully you do realize why is this in a calculator paper, mainly because these numbers are too big to factorize, and therefore we have to use the Quadratic formula. If you don't know why is the Quadratic formula, have a look at the video I've done about Quadratic formula. So what we found out is 14.5 and minus 16. So one is decimal, one is negative. We can't have a decimal term. We can't have a negative term either. Therefore, 465 is not in the sequence. Now, one thing I do have to say is you must make sure your nth term is correct, because if this is wrong, these steps will be all wrong as well. Okay, so I hope you understand everything about quadratic sequences.